Okay, here's an equilibrium problem that requires using something called an ice table, or at least doing the equivalent of that in your head. This is the real meat and potatoes parts of equilibrium, and most questions involve this type of analysis. I'll show you a quick way to do these in your head whenever you can, which isn't always, and then the slow, reliable ice table method that delineates everything. We're going to do several examples of these, so if you want, watch several of these slides before you get a nice feel for it, and then dive into the problems that are assigned. Okay, so in this chemical reaction, we have iron 3 plus. Of course, that wouldn't be just add iron 3 plus. It would be in the form of something like iron 3 chloride, something like that. Similarly, this thiocyanate would be potassium thiocyanate, something like that. But those two ions combine to form yet another charged species. I'm not going to try to name this. I'll just call it FeSCN2 plus. Perhaps the iron thiocyanate ion. And it gives you the values. Notice everything's in solution, so we could write the equilibrium constant expression. We wouldn't have to omit anything. Notice also that there's no coefficients to deal with, so we don't have any exponents. And here's the conditions that they give you. They're going to give you enough data to solve the problem. They tell you the concentration of the iron 3 plus, nice, it's 6 molar. They tell you the concentration of the thiocyanate ion, it's 10 molar, fine. And they tell you when you're done, the concentration of the product is 4 molar. Now, what's the value for the equilibrium constant? Well, we want to write what it is at equilibrium, not initial. Those are initial data. So at equilibrium, we do have that number, which is going to show up at the top. But here, what are those going to be? Here's the key thing to understand. Initially, you got none of this, right? If this goes from 0 to 4 molar, it increased by 4 moles per liter. The stoichiometry of this reaction tells you that since they're 1-to-1 coefficients, this must have gone down by 4 moles per liter. This must have also gone down by 4 moles per liter. So I know how to set it up entirely. It's going to be the concentration of products over reactants. This one on top is going to be your 4. These two on the bottom are each going to go down by 4. So this is going to be 2, and that's going to be 6. Boom, I got it, and I can get you the equilibrium constant. That's the fast way. So there it is right there. We start by writing what you know. We know that that's how we set up the expression. Notice no coefficients, so no exponents, and nothing got removed because everything's in solution, aqueous, aqueous, aqueous. And the only thing we know is the top number. I might have said the bottom number, but it's the top number, right? Right there. We don't know what those are, but if this went up by 4, those two went down by 4. So it's 2 and 6, and there's your equilibrium constant, no units, done. If you prefer, and I'd say just about every textbook and instructor recommends writing a nice table, that means initial change in equilibrium. Start with the same system, what you need to figure out. Write the chemical reaction and set up the table with initial change in equilibrium, because the initial concentrations are given, 6 and 10. The change is given because it goes up to 4 at equilibrium. Therefore, it increased by 4. Those must decrease by 4. Note that's what we did in our head. That's how we got the 2 and the 6. For simple systems like this, you don't need to set up a nice table, I don't think. And there's your values, plug them in, and you get the same answer. So that is a equilibrium problem that uses, if you want, a nice table. Be aware that there will be problems later on where, wow, it gets complicated enough that you really can't get away from a nice table unless you can do a million things in your head, which you probably shouldn't, especially for double checking on an exam. So the ice table method is something you should learn. As a strategy for saving time for basic problems like this, you may want to skip it.